And when I came out of my school, I did some business where I wrote a book that makes the public.
You wrote a book.
Which makes the public exams easy. So in India, we have the public exams.
So you have, you've written a book to cheat on exams,
exactly,
more or less.
It was like.
The following is a conversation together with Melvin Francis, an expert for network technologies, and especially one of those experts which is doing the stuff and not only talking about that. Very important fact for industries, I think at least. As you realized, this one is in English, and if you want me to do more English stuff, just post a comment. If you like that channel, just subscribe, and now have fun with the conversation together with Melvin Francis. So Melvin, you're one of those hidden experts, very deep into network and all of that stuff. And actually, I want to start with a simple question. What is TSN about? Just briefly describe, how does it work? What is it all about? And why are people talking about time-sensitive networking at all?
So a quick brief history about where I started. So it was like 8 years, it's been a decade I'm into industrial automation, and I started with a protocol called Open Power Link. I think this is the Open CAN over Ethernet. So this was a protocol that was designed, like being maintained by BNR, Bernecker and Rainer from Austria. So I was one of the developers who was maintaining this stack. It's an open source stack, and I was maintaining it at GitHub, and we were giving releases on it, and it was a very good protocol, and that's where I started. And also I had experience with Profinet, EtherCAT, and things were going good. And suddenly during 2017, so they decided that for industrial automation to go to the next level and to adopt Industry 4.0 and smart factory concepts to be implemented. So we need a protocol that is being able to be open, vendor independent. It's not like just X protocol being managed by X company and they have everything in a closed source. So everything had to be open. So they decided that OPCA can be a very good candidate. So having OPCA itself is not just the essence, because OPCA is not time critical. So for to have a deterministic network and for to be used in a critical time critical systems, you need determinism, and that's when they decided to add TSN on like OPCA on top of TSN. So OPCA has multiple transport layer protocols, like it can have TCP/IP, UDP, raw Ethernet frames, MQTT, AMQP. So since it has like multiple transport layers, it can use TSN and become deterministic on the machine-to-machine communication. And for machine-to-cloud communication, it can use TCP/IP and MQTT for the IoT purposes.
Okay, so the TSN is somewhere at the lower part of that Ethernet standard, and by that allows anything to be time critical and to have deterministic high performance throughput in an Ethernet network. Awesome. How is it working? What is TSN doing better than the old stuff?
So the old stuff, so let me not go into the proprietary protocol so that I don't hurt people's feelings. So I'll take so let me take an open source protocol. So for example, PowerLink can work in cycle times of 1 ms or 2 ms or 5 ms. Ms is like 5 millisecond cycle time, like sending one signal to the slave. Master can send one signal to 10 slaves for every 1 ms cycle time. It was good. It is easy to do it on a Linux, or you can do it on Windows. It's easy. But when you want to go into sub millisecond cycle time, that is like 250 microseconds, or which is like very high speed transmissions, to send to one packet for every 250 microseconds to all the slaves, it cannot be done with the regular hardware. You need special hardware, you need kernel drivers or special drivers that are lying down on the physical layer, and layer 1 and layer 2. In the data link layer, you need high performance network cards to be done there. So this adds a lot of problem. But when you are talking about TSN, once we implement TSN on these layers, the protocol that is lying on top need not worry about these cases. So everything on determinism network is being handled by TSN, and on top of it, the protocol can just use the underlying resources, and then it can send in packets without worrying about the network and like will the packet go to the slave or not. It need not worry about that. TSN is going to take care of it.
Exactly. TSN is split up into several parts. Like the standard has a lot to say, but there are a few main parts. Like one for time synchronization. That one is quite old, actually. It exists, I don't know, like 10 years ago. It's old. It's really old. Then the second part, which came new to it, was scheduling, and then somehow that preemption, which is additionally needed to get some good scheduling of big packages, actually. Just let's talk about the first two. What about that time synchronization? What is that?
Yeah, so TSN itself is not a single standard. It's a collection of IEEE Q standards, and for TSN to work, the most basic thing is 802.1 AS time synchronization. So once you have the time sync done, and then the next items in the TSN standards can start working in. So time synchronization is the most important part.
Okay. And then the next part, the scheduling, is I think the most important thing. So what does it do actually?
Scheduling, I think we can start with the real world example of how I can. So I think few of them watching this will be very new to TSN. So so to explain TSN in a very simple terms, I can talk with a real world example. So imagine there is a meeting room. So there are 8 people in the meeting room. Everybody are talking to each other. So there is a huge chaos. So there are few people talking very important information, but few people are chatting and they are gossiping, and the most important information and the other information are mixed together, and then everything collides with each other, and then the information is being lost. So what happens is, in this 8 people group, they decide that there is a problem. So they identified that that's a good thing, right? So they identified there is some problem happening. So they all come together, and then they decide like we need to overcome this problem of information being lost, and things are not going well in our meeting. So what they do is they decide like everybody should have the clock synchronized. So how can their watches be synchronized with the same time is like they decide one person in the room should be the master. So his watch will be the grandmaster clock. And then what he does is like he shouts the time. So now the time is 9:05. Everybody who's 9:06 come back to me, and whoever is 9:04 come in front of me. So everybody are adjusting the clock either front, either back, and then they go front and back, and then they are all in the same time. And now when the master guy says that the time is 9:05, everybody are having the same time. So now what happens, the group which was disoriented, now at least they have all their clocks synchronized. Same time. So this is 802.1 AS in the real world. So now that they have all the time together, the group comes back together, and then they decide, let us have a session of 80 seconds. So this session is going to repeat in cycles. So every 80 seconds there will be one session. So what they decide is that all the 8 people in the group gets a slot in this 80 seconds to talk. And even to make the calculations easy, everybody gets equal slot now. So 0 to 10 seconds is for person 1, 0 to 10 to 20 is for person 2, and it goes on. So the last person gets to talk at 70 to 80 seconds. So imagine if I have to talk some content for 30 seconds. So how many sessions I would need? I would need 3 sessions to talk. So because every session I get to talk only 10 seconds, and then I need to give my information at every time. So now all the people are getting their time to talk, and when one person talks, all the other people should listen, and they are not talking in the same time. So
that's exactly what happens actually. As I remember, kind of Ethernet defined that using the cable that way that the person who wants to talk on the cable has to listen to the cable and only is allowed to talk when it's free, you know. And now what you say is kind of we improve that one, and not everybody has to listen all the time to the cable, and not everybody tries to talk at that moment he wants to talk, but everybody gets a very polite slot to talk to each other, and nobody has to think about when to talk or test when to talk or whatsoever. That's great. And so that makes it possible we get a very high performance in senses of deterministic communication, meaning that performance concerning the value of data, you know, the pure size of the data, that was very good already. But now we have something which guarantees us that every millisecond there will be some message at my place, and I can place some message out there. And that's somehow is the important part for industries, talking about PLCs and programming of machines, because as you can imagine, whenever there's a robot arm, it's not good. When it gets commanded every 5 milliseconds, then every 50 milliseconds, and that would produce too much overhead, and it would be a great problem for industries. Anyways, TSN itself is not focused for industries, actually, I think.
So as I told you now, in this group of people, like now 802.1 QBV is there, and then they have allocated time. So previously all the traffic was mixed. Now all the traffic gets, I think you can add the image in the down, like with QBV on and QBV off, which gives a clear perspective. So this history of what you are asking is like TSN was TSN only particularly for industry? The answer is no. Previously the name was Open AVB, Audio Video Bridging Protocol. It was mainly used for audio and video to be synchronized. So it was used in the entertainment industry, where in the concerts we can see like huge screens, and then there will be many number of speakers. Speakers in the sense like not like sound speakers, which gives you the sound. So to get a good experience, what we watch and what we hear should synchronize together. So even if there is a 1 millisecond delay, then we can start, our brain can start.
Especially when it's changing its delay, that's awkward. If you have 10 milliseconds, that's okay. You can work with that. You can say, so everything is 10 milliseconds behind, but the latest person will be able to speak at the right moment, but it's not changing all the time.
So it was primarily used for entertainment industry, and then it was mainly it was used by the automotive industry. For the infotainment system, it was clearly used. Right now the
kind of a TSN was used, or that's time synchronization.
The AVB part was used, audio video bridging protocol.
Got you. And that ABB part is some foundation of that TSN parts which came above of that. And so that other parts add something to that, or
So
do they take parts and change them to be more proper for general use?
They use more of scheduled traffic, frame preemptions, and quality of service is more used in these industries. And TSN is just for the usage of these standards in industrial automation.
It's specific for industry.
Exactly.
TSN. Okay, I see. I didn't. That was not too clear for me, because in the end, it's on the very low standards. It's an Ethernet standard, so everybody could use it. Actually. Will be able to use it, because all of those network cards, all of that hardware will support TSN within the next 5 years. I think that is something which will come, and if you buy a new switch, that will be able to do TSN. So everybody could use it. Do you think that's something everybody will use?
Being in this field for a long time, at least for 7 years, we are looking exactly what's happening inside TSN. So previously the switch prices were 5 digits. So now it has reduced to like a couple of years back it was 4 digits, and now I could say we are able to get it in 3-digit numbers. So how just like the more the production is, the less the price, right? So we can see like more switches are being produced, and we are able to get it for 1,500 euros, and there are websites where you can go, click and add it to the cart and you can buy a switch now, which was not possible previously. So even right now in our demo, we have a very small TSN device which runs on ARM platform, and it has 3 ports which can act as a bridge device. So it can take in a signal. So bridge device is where in industry automation line topology is very important, right? So that reduces the cabling and it's very mandatory. And we have devices, the chips which are low-cost chips which can do TSN.
Bridging. That means you have kind of a small switch integrated
exactly
on your thing. That is something people already did. As you said, it's very mandatory to have that daisy chain like networks all along. Like the other Fieldbuses did. So I'm talking about Fieldbuses. Is there any Fieldbus you are into, or do you think TSN will do it all?
So right now, industrial automation is not a field like SaaS industry with software services. It's not like the disruption will happen so fast. It's a very conservative industry.
Yes.
And something to get being adopted, it takes a long period of time because a lot of investments has gone in already. So what we are seeing is the current Fieldbus protocols will use TSN for a while, and it will also use OPC UA on top of it for certain communications and configurations. We don't see like the industry quickly switching to OPC UA and TSN immediately. Maybe next year. It's not going to happen that way. The adoption is going to be a ramp down for other technologies, and ramp up will happen. But who knows? It might evolve. So.
Yes, for me it's kind of, there are a lot of Ethernet standards out there, especially EtherCAT. That performance is amazing, crazy amazing. It's just when you're about deterministic performance, you will do EtherCAT somehow. Even if there is TSN, it still will be EtherCAT if you need that crazy nanosecond synchronization stuff and all of that. And moreover, EtherCAT is also available for standard Ethernet networks. So there was a time whenever you had your EtherCAT running on your home network would shut down. But right now there are switches and they can cope with that, and so you can run your EtherCAT through your normal Ethernet network. In the end, at that point, you are where TSN is. You don't get that crazy performance out of that anymore.
So I want to add one thing, a concept of 8 traffic classes. So there's a definition like in a real world network, right? So there is 2 types of networks. One is IT network and one is OT network. So IT network, something like when you are in a factory floor and you get the traffic from the CCTV cameras, you get the audio, video data, and also there is some enterprise level communication like configuration, getting a historic data from the devices. So these are different traffics. And also there are some traffics that needs to be done for the mission to mission, which is called as isochronous traffic. So like this, there are 8 traffic classes. So previously there was a split between the IT network and the OT network. So as you said, once you connect the EtherCAT into the IT network, the IT crashes. So with TSN, everything gets their own slots to communicate. So just like we discussed, right? So they can all coexist together.
So you increase the number of slots from 2 to 8?
So even in one slot, there can be multiple traffics also can coexist. So the most important thing is the video traffic can also have a small delay, but the robot's control data has to be there every time. So there's dedicated slot that is given for this isochronous data. That's the most important thing. And all the other stuff can wait for a later period of time. But this has to go and reach the robot slaves as guaranteed as possible. So this is when there is new business cases comes in. So previously these 2 networks were different. Different resources are needed, so it becomes more costly, more maintenance is needed. Now they both are together. So what happens is that the sensor data can easily flow through to the top.
That's funny because everybody is doing something like CAN over TSN or EtherCAT over TSN and all of that stuff. That makes it funny for me. When I read about EtherCAT over TSN, I thought, that's for what reason I would do that actually, because everything would work the other way around too. But to make a point out of it, having TSN, it's absolutely, you can send anything in high performance deterministic. You don't need that. The Fieldbus only brings along some definition around of that, how to transfer the data, how the data looks like, but it doesn't do anything about the techniques and down there. And that's the reason for OPC UA and OPC PubSub actually. So why do you think OPC UA and PubSub will be, or do you think that will be the standard for industry? It's growing. It's really growing. And for me, OPC UA is large. It's just big. On the other hand, you have publisher and subscriber, and that's I think the third publisher subscriber system I read about. First there was MQTT. Google had something going on, publisher. Somehow the most stuff is publisher and subscriber. And now we have some OPC publisher and subscriber stuff. So that's just small packages. And on the other hand, the data is not defined very well or very strictly. On the other hand, for OPC UA, the client server system, the data is well defined. You have that node system. That's awesome. That's object oriented. You can combine that very good.
So for your question of when you are confused about publisher subscriber model, right? So what is publisher subscriber, MQTT and OPCA? So people might confuse it. So to give an example, those water bottle, right? This plastic is a container that you are having. So with this container, you are able to transport this water, right? You can, it's safe and you can take it anywhere. So this container is MQTT. So MQTT is a transport layer protocol. It's not itself a protocol where you can understand what's there inside inside the bottle. So you can also send now we have water inside. You can also send juice. You can also send beer, or you can send whatever you want with this plastic bottle.
So let's assume beer.
Yeah, this is like a transport case that we have. So MQTT is a transport layer, but having OPCA data inside it, the OPCA data model and the information model gives more meaning to the data that is being sent. So it becomes easy in the data modeling aspects. So MQTT then, so for example, if somebody uses a sensor value that sends temperature, so the user has to define its own way of sending the temperature, right? So even for as basic as temperature, it needs like what is the maximum, what is the minimum, what is the unit of the temperature, is it scaled, is it like how many decimal numbers, there will be at least 10 parameters for as simple as a temperature. So when you are defining your own way of sending it through MQTT, it takes a lot of problem. But once you have OPCA information modeling, then it gives the metadata, it gives you all the information about what is being sent inside this container. So that's the good part of OPCA.
That's a really good part. But along come those companion specifications. You know, in the end, you have that information model. As far as it concerns me, and that's great. That gives that gives some structure, which implies you should tell what data you're transferring. But you don't have to do it like that. And depending on the industry, depending on the company, whatsoever, you will design your data in another node network, in another information model. And now there are those companion specs where some industries try to get together and define information or information models for certain industry aspects or for certain use cases. Do you think that will work out in the end concerning those companion specs? That's a point which, for me, it's again, you said it's a very slow industry. It's very slowly adapting. And that's a point where I suspect that everybody will be on that.
Exactly. So what we see is more and more companion specifications are being created for the ease of adoption of OPCA. Yeah, you drink some MQTT. Yeah, so there is, for example, there is a companion specification for plastic forming industry, like when you have a plastic forming machine, what are the parameters that you need to do? So for temperature itself, it's 10. Then imagine like how much complicated will be to adjust a motor or a pressure valve or something. And then there is also for oil and gas, there is a separate companion specification. So there are like enough specifications are being formed for these industries so that the data modeling can be as simple as possible. And once you import this data model in an XML file or something, and then you get a tool, and then you can import, for example, if your device has 10 sensors and 10 actuators, you just add like 1, 2, 3, 4, 10, you drag and drop, you add 10 actuators, and then you connect the links between them, and then you get your information.
So the goal is also to get a better usability through the proper software architecture,
Exactly.
the right software tools, which allow you in the end to really drag and drop your sensors into your industry focus. What were the main technical issues about TSN to overcome? Like, why did it take so long?
It took so long for multiple reasons, but to keep as political as right, and also just talking about in an engineer's perspective, let me not take it to the history or something. TSN is very difficult to test. So for example, so to get a feel about what's happening inside a system, so for someone who has been working with RS-232 or RS-485 Modbus or CAN, and if they want to move to TSN directly, all the terms that we spoke right now will make sense to them, but you will not get a real feel about what's happening inside the system. And for example, if you say time synchronization, even having synchronized 1 minute in the level of seconds synchronized is also good. Being synchronized, like what I'm saying, synchronized is like the master is synchronized to a slave in terms of nanoseconds is the best. So even being synchronized in milliseconds, like if your time is 10, even if it is like 15 milliseconds away, it is synchronized. But to what level? So people are a bit confused about that. And then when you're talking about QBV, like you have to send this frame in this slot, people don't understand it. So once if they want to understand, they need testing systems in place, and these testing systems are very costly. The costly in the sense, like they are, if you want a best system in the world, then it's like 100K, and if you want a decent system, it's like 10K euros you have to spend just for testing.
Meaning that degree of time synchronization. So when I want to do synchronization on the nanosecond scale, I have to pay for it.
No, it's not pay. Your systems can do it in nanosecond level, but to know that it is being done in the testing ecosystem is what
testing ecosystem. It's that okay. That's all right.
So it becomes like
so the testing system has to be one step further away, so it's not about nanoseconds, but about picoseconds for that testing system.
So that's where the entry barrier is like this entry barrier for new adopters is very difficult for them to understand the test system, and for them to build something on their own is, again, it's going to take a lot of time. So that's where in this project, what we have done in our research project recently is we are developing a testing system that is going to be so cheap that you can just buy the software from us, and you can get your hardware setup being done just by buying stuff from Amazon. Everything can be done. The hardware part is not going to be more than 200 euros or 300 euros, and then our software parts will help you to diagnose your system.
It's working.
Exactly.
I see. That makes sense to me. Like that means the testing was awkwardly expensive, and most people weren't able to just test their systems.
Exactly. Even if they are, if there is TSN running, and imagine you are coming to me and asking me like, is TSN running in your system?
That's another aspect which is problematic about that. When you are not able to test it, nobody will buy it, because nobody knows if that TSN stuff you are selling is really doing TSN in a proper way. Okay, I see. And in the end, I think those oscilloscopes, they were available.
Exactly.
To say it. I still don't get the point why it took 7 years. You could have used those oscilloscopes, and most companies, at least the big companies, they won't care about that 10K oscilloscope they need for that.
Yeah, the problem was TSN itself, when everything was started, the FLC group was formed inside OPC Foundation, and there were many Plugfest happening and series of Plugfest happening, and The problem was to get the hardware being cheap. So hardware being cheap, and the chip vendors has to produce them, and for chip vendors to produce them, they need machine builders to start building machines, so that they develop 100, they produce 100K chips, and then it has to be procured by someone. So these things were again a chicken and egg story, and again the standards itself was not complete. There were like many questions has to be answered yet. So for example, the other field bus protocols, everything was done by a single entity, right? So one company takes it and then they define the standards. So now it's going to be vendor independent, and there are many people coming together, and it has to address many other aspects like how everybody's missions can coexist in this part. So the standard itself was evolving, and COVID again, 2 years, solid 2 years was a stop to this, because you might ask, like, you could work over remote, right? TSN doesn't work that way. So we are working on Ethernet, and it has to be plugged. And so for example, I sit here in Kempton, and I cannot say my system would work well that is being developed in the US unless and until we both meet together and plug it together, test. So these were very important, and it got slowed down. But whatever we are seeing in the last 1 year, there is a big spike which we are seeing in the interest of OPC and TSN. And just we came from Embedded World day before yesterday, and I was able to present in a conference. So what we heard, that in the previous year there were only 7 people in the room, but when I presented, there were like it had 40 seats, and it was full, and people had to stand in the back to listen to our conference proceedings. So
that's, I think the interest is growing. It's rapidly growing. I think especially because also of OPC UA, you know, the client server system, people got into contact with that. All the visualization systems are using OPC UA normally right now. And so everybody knows, oh, that's somehow great. I can use it. Yeah, there are those clients out there. I can watch the network. I can see what data is driven in there. And now if you get that stuff to real time, or at least part of it to real time, it's awesome. What do you think about explicitly OPC UA, the client server system, over TSN? Does that make sense?
No. So client server is a connection protocol, right? So on the over TSN, or when you need to connect mission to mission.
I'm asking for one purpose. People ask me about was they have a visualization, and they don't want to have times going from 40 milliseconds to 100 milliseconds for the data update.
Okay.
And so using OPC UA, somehow they got there, and they were asking about does TSN support me with that issue?
Yeah, so TSN can...
You know, it's slow times, but deterministic slow times.
Yeah, so when you're using client-server model, TSN doesn't stop you from doing it. So TSN can accept all types of traffics. So it's all about like how you configure TSN. Like you give a slot for your client-server traffic, and it is going to flow through. So people need not worry about it if they are not worried about the time. Even if, like for example, not every use case is a sub-millisecond, right? So there are some use cases where 100 milliseconds is fine. And they can use a client-server model. That's totally fine. But what I would suggest is, instead of going into client-server model, they can go into OPCA pops up over MQTT with the broker middleware. So there's a middle broker, data broker that gets all the data, and the subscribers can subscribe to the data. So that will be a better architecture than going into the client server.
You're right. Somehow for the visualizations, anyways, a publisher subscriber system makes more sense, because you have the publisher is your PLC. And let's stay a little bit at the technical place. Right now we have a lot of copper cables used for Ethernet. Do you think that will be replaced by the fibers? You know, the Ethernet standard, it comprises some fibers. Do you think that will be necessary for future networks, or is it some nice to have?
So as in the technology front, I have not explored much, but will there be a need for something better? So I can give you an idea. So there are multiple types of Ethernet links, right? So 10 Mbit, 1 Mbit, 10 Mbit, now gigabit, and there's going to be like 25 gigs of link speeds, right? So right now, what we are able to see when we go into this plug fest where everybody comes in, and even we have switch vendors. So what they are saying is that even 1 GB, 1 gig network is not used completely. But right now, yeah, it's more than enough. And now 10 gigs and 25 gigs when it comes in, I think there's a long way.
And you know that those 10 gigs, they get over the copper cables still, or you don't need
you need the same cables. There's no different cables that you would use. So the problem is both the devices should support this. So they auto negotiate their speeds, their link speeds, and then they decide on, so if 10 Mbit is going to be my max, then this, even the device is 25 gigs, there's no use. So they need to auto negotiate and decide on a link speed.
Okay, I see. So right now it's not looking like we have.
Yeah, we need a better one or anything. Yeah.
Okay, awesome. Now let's take some step back. We have TSN. That looks like everybody is happy about that right now. But what is after TSN?
Yeah. So
what are people thinking about?
Yeah. So what is after TSN? So I have maybe my wife works in SaaS industry, like software as a service. Yeah. So what happened in SaaS industry will happen in industrial automation is what I strongly believe in. So for example, there are new business models in SaaS industries that we saw in the last 5 years. So SaaS in the sense like HRM or CRMs or whatever we use, like Monday.com or Calendly. So all these have different types of business models, like pay-per-use model. You can use Calendly for just one event, and then you have subscription models, and then there are concepts like just-in-time. For example, your warehouse can get so storing the, for example, Amazon. When you have a warehouse, so people will order 10 and then they use AI techniques to say that you need 10 shoes to send it to 10 people. Like there is a regular ordering, but to store this 10 shoes in their warehouse, it's going to take some cost to maintain it, right? So imagine like everything is connected, and the moment the order is placed, then only this shoe comes into the warehouse, and if it is going to be delivered to the customer, so this is called as just-in-time concept. So imagine like you need 10 screws to fix in your car in the production line. If the screw is 2, then the enterprise goes and gives alert to the logistics department, and then only the procurement happens. So the procurement is not like you buy 100,000 screws and you save it. You need to make sure the temperature is right. It should not get rusted, and you need a person to monitor it. The cost adds, right? So this is where just-in-time concept comes in. And next is the most interesting stuff that I'm looking forward is one batch per piece. So one piece per batch. So what is like, for example, if you imagine a car in the car industry, if an X car is being manufactured in white color, there will be like 100 cars being done in a batch. And then black will be 100. And then blue will be 100. And for example, there's a crazy neon color. 100 people are not going to buy it, and this 100 cars are going to wait there. So once you know like what your customer wants to order, and everything, like you have this just-in-time logistic, everything interconnected, there can be, imagine a customer wants green seats and an yellow colored car. There can be one piece in this entire batch where everything is connected. You get the paint that is needed. Everything is interconnected. And for this to happen, you need the connectivity from sensor to cloud. IIoT has to come in, Industry 4.0, smart factory, all these concepts has to come in. So my philosophy is, will OPCA and TSN will do it or not? I'm still skeptical about it, but there will be some protocol that is going to do it. So all that I'm going to wait is to understand which is going to help out these concepts, and we are going to follow it. So this is our philosophy.
Yeah, you're totally right. I'm totally with you. Like that concept, everybody orders, especially, or that special thing designed only for him. And that's where the industry is aiming. That's all. That's for me. That's one reason why robotics is the 6-axis robots are getting so important and so famous. Let's say right now, because they are able to do anything basically. But right now in no sense can compete with those highly specialized automatic machines which produce just that only type of a screw or that only type of a car. Especially the automotive industry is relatively far into that stuff of, you know, you order your car and you have a lot of options you can choose from right now. But right now those lines are kind of still restricted. You know, you cannot choose the form of your chassis, for example, or something like that. And I'm not sure if that is something the people would want to do actually, because that makes it, you know, life is already quite complex. Having all of that stuff around us, and now that would make it even more complex. Awesome. Moreover, I'm with you. We just don't know what will happen, but we see a lot of stuff on the software side which somehow has to come to the industry side.
Exactly. Yeah.
And we don't know what that will make out of all of those standards we're using right now. Nice. Perhaps to finish that discussion, what were the essentials of your career? What was important to get into networking like you got into it? And what drove you? You know, what was that thing you were aiming for?
Yep. So always from high school, I was very much interested in starting a business, and I need to have my own business. And I did, even after I came out of my school, I did some business where I wrote a book that makes the public.
You wrote a book.
Which makes the public exams easy. So in India, we have the public exams.
So you have, you've written a book to cheat on exams, more or less.
It was like a small guide that helps people to.
Is it still sold?
Yeah.
So we need to post a link actually.
Yeah. No, the problem is in India the syllabus changes every. So it was just for that one particular. It was for French actually. I wrote. I don't remember any more French, but I wrote like the French language was like just you learn it for 2 years and then you appear for the exam. So it was basics. So we gave some hints and all the antonyms, synonyms. We gave tricks to write their own essays. Like you have like first 4 lines of the passage was given, and the last 4 was given, and the rest you write the question again in the middle. Then your letter is ready. Your leave letter or your letter to your thing is ready. And so we gave some hints to the students, and it sold well. And then once we came to college,
so that was your first business model to help students.
Exactly. And then after once we got into college, as I started to read, we understood like having providing software as a service would be good. So we developed websites for companies. So previously there was no Wix.com where you can drag and drop stuff, right? So people needed help. So we earned a lot of money, and then also we went to colleges to teach embedded systems. So we were students, and we were getting all these Arduino kits, Raspberry Pi kits, and then we did some programs. So we did go to college and collected like per student it was like 10 euros, and then you can sit in a class for 2 days. You will know Raspberry Pi when you leave. So we did few business, and then we thought things that we are doing were very small and it's not going to create an impact. So we decided to go and
the impact you were aiming for, was it a financial impact, or was it more or less a social impact?
Yeah, the social impact, and more than social or financial, that is there, but we wanted to go global. So whatever we were doing, we thought we would be confined to a very small space, and even if we were earning money, it was not enough to create a technology that will be used for a long time, or we will be the leaders in a space of embedded systems was always our interest. So we always wanted to be in, so when I say we, it was me and my friends who all were in this business. And then we decided to join different companies. And when we chose this company, we wanted to go and work in a small company where the people are like 20 to 30. And instead of becoming an entrepreneur, we all became intrapreneurs. So what is intrapreneur is like when you go into a company and you think that this is your business and you do all the stuff that is needed for the company to grow. So, for example, I used to go as early as possible to the company. Right after my graduation, I used to go early. I used to clean the desk. I used to, normally it doesn't happen that way in India. Like, you have people for everything to do, right? So I make sure that everything is ready when the people are there. So I used to be the first one to come and the last one to leave. I did marketing, I did sales, I did technical development. I posted stuff on LinkedIn. I helped for recruitment. It was I treated it like my company. I was there in their business meetings, business plan meetings, and even the company was also helping. Since it was a small company, I was not confined to one role. I was able to everything. And also the reason to join BE services also is the same. So I get to given all the ideas. So one thing that is needed when you are an entrepreneur, like when you are working in a company, is always be aligned to the missions of the mission statement of the company and the values of the company.
I see, but in the end, you are very free. In a small company, you are free to explore yourself, your own abilities.
Yeah.
And your own
so
interests.
Unless and until I'm in line with the goals of the company, everything is fine.
Yeah.
So I should not do. So we are an embedded company. I cannot start selling some fruits or selling some.
Was it a decent decision to come to Germany, or was it just kind of randomly choosing a country?
No, it was not like that. I used to travel to many companies many countries for business. I've been to at least right now it's like 10 to 15 countries already. I've been to, and out of that, I liked Germany and Austria because of the work culture and
the beer.
Obviously. Yeah, that's there. That's very important. That was very important. The work culture was good.
What did you like about the working culture?
Yeah, so it's like the best part is the vacation, 30 days of vacation, and your sick leave and vacation is not the same.
Is that vacation important for you, or are you the guy which still works in vacation but works on stuff?
No, it's not like that. I take vacation which is cuts me off work. So recently I took vacation to get my paragliding pilot license. Yeah, so that was really good. And yeah, obviously when you do something like that, you can't access your office emails or you're so busy.
That's a good point. Actually, for me, it's kind of hard right now. I'm honest right now. I think it's kind of like 7 days a year. I really get off. You know, I really put the stuff away. But I think it's kind of depending on the work you're doing and what you want to do, and if you don't like it, or especially when you have something to do, like you said, you do your paragliding license, then you are totally off. That's something I should do. Presumably should do someday. Not paragliding, but to choose something to do and to do something which is really different.
Yeah, so the reason for me to choose something like that is because in work, we had Embedded World like a couple of days back, and we worked through all weekends, like 3 weekends. We worked as a team together to pull this off because we had our conference presentation. We had to create this paper, published presentations, demo, and we had like a lot of stuff going on. But when we are, the reason for me to choose something totally off is because you need a different kind of discipline to do this paragliding, or when you go for biking, or when you run a marathon, the discipline and your system changes where it's like totally, you have to eat right, you have to sleep right, and then you're becoming a different person during that time when you try that.
You're right.
It gives me a clear cut from work, and I would say like it gives me a different perspective to work when I'm there, and then once I'm back to work, I'm getting more fresh ideas. I'm able to do.
Your view has changed. You have another view to the stuff. Yeah, I'm with you. Actually, for me, I'm doing a lot of stuff in parallel. Kind of. I'm doing a lot of musics and other things all along with that. But it's especially important to get. To free up your head to get new ideas.
Yep. So you're a star in your
kind of
in your band. Right?
I never was a star. Actually, I'm playing the trombone and some other instruments and singing along. And I was drumming actually, but no, that's kind of a hobby for me. So we'll keep that away from the official stuff. Or I try to keep that away from the official stuff. And most of the people I'm talking at the university don't know that I'm doing something else. They only see me answering my emails at times one should not answer to emails, actually. Yes. In the end, are there some other aspects along to the vacations which you liked for the working culture here?
So one thing is I'm able to travel more and meet people. So industrial automation, when you talk about it, Germany is the center, and
that's somehow still true, but it's.
So we are feeling that we are very close to. I'm feeling like we are very close to the customers here, and whenever we go to the trade fairs, we hardly find time for standing out or to see the other booths, because we are always filled to meet our friends and colleagues there.
You're right. I think that's true. On the other side, the Germans do that because they think they have to do that. You know, they think they have to talk about all the new stuff. But in the end, that's just my opinion. They tend to just talk about that new stuff, but in the end don't do it until it's so safe and so commonly used. There's at least no risk you take when you're using a new technology. Exactly. That's something which is not. It's a good thing and a bad thing at the same time. You know, you get a really decent technology on the one side, but you are not very likely to find something awesome new, or to create something new. Okay, Melvin, thank you very much.
Yep, the pleasure is ours. And
still, I think you are one of those hidden experts when it's about networks, and it was a pleasure for me to talk to you.
Yep, thanks for visiting our office, and we are very close by. So all the while I've been coming to the university, so thanks for dropping by, and I think.